Welcome. My name is Markus. I'm actually German, working for Lightband as a developer advocate. I have to admit I do a lot more than just speaking and talking to developers, and I still do code a little. I have a comparably solid background of 14 years of consulting, like being out with customers, like in the field, fixing issues. But my background is more Java and Java-EE. So having me here is kind of a weird thing, and I agree. But I'm trying to talk about something that you all at least have heard about, because there's been a couple of other sessions diving into that a little bit more deeper, and that's a new framework like Lagom, named Lagom, which is Swedish. Who has been attending a Lagom session already? Oh, fair. Okay. So I'm not going to show you anything today in terms of source code. I would like to introduce you a little bit more to the motivations behind microservices and why this is actually a hype. And a little bit more what I think makes microservices a lot better approach than traditional application development. You all should have received a very nice little 60-something pages book in your attendee packs. That was actually me. So whenever you're feeling bored on your way back tonight or tomorrow, give it a nice read. I have to admit it's also about the Java API in Lagom, but it should give you a nice head start. And surprisingly, we will have a Scala API. So it's definitely something to get you prepped and ready whenever the Scala API is there finally. If you want to reach out to me, the best way to do that is actually Twitter. I'm just waiting for the day where my wife starts to tweet at me to do something, but hasn't happened yet. Otherwise, just drop me an email. I should be there. Who did ever write that kind of code? A couple of hands go up. So yeah, that's Java EE, kind of CQRS, REST services. Looks pretty solid, does it? Like order processing, very nice, awesome stuff. Everybody's talking about microservices, as do I today. And the funny part is, haven't we been doing that? Like everybody's talking about REST endpoints. Everybody's talking about like putting REST endpoints together. And if we take that classical thing here, which you probably will find in many enterprises, like you're knocking at the door at a customer and you have that great toolkit of Akka and Play and all kinds of fancy technologies. And this is exactly what you get as a spec. So they're calling you, and we don't have real business document. This is like source code, this is Java EE, make that microservices, please. And make it a good one. That's basically what they're asking for, right? So something that is not necessarily fast, but it has worked for many, many years. We'd like to call it the monolith, right? And I intentionally took apart a very old Ferrari here. So I think it might have been top-notch technology just 10 years back. And now we have this thing, and this thing, monolithic application developed by very bright minds, needs to move forward. We need to introduce new business requirements. We're working in an insurance context, and we just want to calculate our policies differently, right? So we actually have to decompose those things. And what could be closer than just ripping everything apart, having all those components, hopefully they are there to a certain extent, and just making all of them REST calls and kind of binding them together again. I tried to do that, at least for one of the calls in this example code. And what you can see is like it's going to be very dirty very, very quickly. So you end up having REST services calling other REST services, calling other REST services, and nobody is really willing to manage that. Seriously not. That can't be the solution at that point. Maybe there are other solutions to that problem. What else could be an issue with just chaining REST services? Performance, right? I mean, that's network calls at the end of the day. And that might be okay if we do a bunch of network calls. I think we all have kind of smartphones today. And the apps basically do exactly that, right? Some back-end calls, REST services calls. but mostly only a tree of the depth of one. So a bunch of services getting called more or less at the same time, deliver all the information that the app actually needs, and we're done. If we're thinking enterprise, if we're thinking component models, we probably will end up having a depth of 5, 6. Each call might end up having a couple of seconds, maybe. Like we're talking legacy, probably. There might be a host system down there. That's so scary. And does anybody know how long our attention span is? Like, how long are we willing to wait for a reply from an application? Other guesses? I think 1 second is pretty close. So you just can't chain REST services. You just can't slice up what you already have and just make REST service out of every component and kind of chain them. Another problem space. How do those enterprises actually package those funny new REST services that everybody is talking about? This is obviously like the Java EE stack and everything that you might want to have if you want to run something, and even like a servlet engine. So you have your deployment units, you have your components, you have your runtime, like the server runtime, you have a virtual machine, you have an operating system. Who has ever done that before? Not a lot, I expected that. Don't worry, we're getting there. The idea is actually enterprises are doing that kind of complex scenarios. And even if we're shaking our heads because we're looking at it from a different technology perspective, this is what everybody is telling the big enterprises out there today. Slice up your infrastructures. Instead of deploying one big monolithic application to your platform of choice, slice it up and deploy millions of little applications and wire them back together with REST services. That doesn't even sound right at that point, right? And another thing that we have in enterprises mostly are large teams. So what's the average team size you guys are working in? Just shout at me. I'm trying to make that an open session for everybody to not fall asleep. 8, 9? 5? Okay, make a guess what the biggest enterprise Java project was that I ever worked in as a technical architect. Good guess. Next one. Not even close. Yeah, it's 200 people. Jesus. Unbelievable, isn't it? So, and this is kind of like a setting that I don't even want to think about, because if we really if vendors are really starting to tell enterprises to just stick with the stack they have, with the teams they have, slice up everything, double the amount of complexity in deployment, double the amount of communication overhead in between the teams, actually breaking up monolithic applications with that approach adds complexity and doesn't take it away. And that's the most interesting part. But for sure, there is a need for having microservices. And the need is pretty clear. So if you look at that little chart, I put actually a couple of weeks times in here. Assumption is that developing a new release of a monolithic system, it doesn't have to be the 200 people thing, could be on average like 36 weeks. Maybe that works. 63 it's actually, right? The other way around, German and English is hard. So if we have a single change by legislation, by some European laws that actually go through to our insurances, and we need to have something in place in a couple of weeks, that's hardly possible for those corporations working in monolithic application settings, right? So they are trying to break that down. And having smaller systems, smaller chunks, actually allows them to put those changes into production a lot easier. And just assuming now you have like 5 or 6 individual components that you have to update for one single requirement change, that might only take a third of the time. Or you have even smaller parts down to individual services, down to microservices, that only might take a day or two or even hours. So this is exactly what enterprises are looking for, because software starts to earn money when it is in production and not when it is in development, right? So the more frequently we can get changes into production, the easier everything gets. So that's pretty much one of the biggest motivations behind microservices. And I really get that. But what nobody is telling you that the one microservice, the first one, is exactly the easy one. But combining everything and building a system out of that really, really works is the super hard part here. I said REST services are not a good way to go, right? So don't even think about replacing existing stuff just one by one. If you want to have a performing microservice architecture, a microservice system, then you need to think about asynchronous communication, which is something that is pretty close to our all hearts. We've been thinking in that kind of dimensions for definitely longer than anybody else, but the enterprises haven't. So keep in mind that this might be the most interesting challenge, moving somebody over from a monolithic, platform-based approach, no matter what technology, into something that is asynchronous and that is a microservice-based system. And there's been a couple of nice talks. One I outlined here is one I really, truly enjoyed. So you can even build a distributed monolithic system if you're not careful enough. So give it a go and just watch that YouTube recording. I really like that one. I talked about how not to build microservice systems, right? But how do we build microservice systems? Who is actually building one right now? 3, 4, 5? Okay, so you actually know the answer to how to build microservice-based systems. Gartner has a very easy answer. They tell us how not to build them. So whatever we find out there, like Java EE, .NET, whatever, just forget about it. That's definitely a dead end. Those outdated application platforms can't be the right thing to start over. I'm not a big fan of Gartner. What I used Gartner for in the past is actually to push through decisions I had to make as an architect. So whenever you have somebody up the line that you really want to convince and you have no other way through it, just find the correct Gartner quote. That most likely works. Seriously. So, trying it from another angle. Gartner doesn't work, and I get it. So here's a quote from me. First of all, the good news. Whatever we learned over the past couple of years is actually still relevant. We will still have our jobs, if it's microservices or not. And I personally believe that architecting those systems in the classical sense and design patterns that we already know get even more important in those distributed complex systems. And this is something that kind of pleased me well and let me at least look forward to those distributed systems. I don't have to relearn everything I already knew, right? So we know a lot of principles out there. Single responsibility. I'm actually not talking about how a microservice looks like, but I want to have an answer from you. How micro does a microservice need to be? So when I first started giving talks around microservices, that was the #1 question I received from the audience. How big is a microservice? Curious to hear your thoughts. Unfair. Unfair. Yeah, it's bounded context. Context is a good guideline to find microservices. Actually, the enterprise Java guys, they were speculating more like lines of code. So they were thinking like, let's talk about 50, 100 lines of code. The best answer I ever got was like 5 kilobytes. And that actually referred to the package jar file. Love it. So bounded context is definitely a good guideline to look for a service, a microservice. Jonas Bonner told that plenty of times already, I think, and I don't like the word micro either because it implies a size, and Did I mention that Lagom actually has a translation into English? So Lagom is Swedish, and it means right size or just the right amount. And I like that. So right-sized services are actually something that we're looking for. I doubt that I can influence the industry strong enough to make everybody talk about right-sized services, but this would be definitely something I truly enjoy. Another lesson that we've been taught in the context of enterprise is actually everything we learned from SOA approaches. So everything that had to do with those service-oriented architectures, call it good or bad, like centralized, ESBs, whatever we had, we learned a couple of lessons, how to have systems communicate with each other. And those principles are still valid, just on another granularity, right? Another really important part to me is everything that has to do with componentization. So encapsulating functionality, reusing functionality where it's valuable and helpful. The Java world especially has been failing on that end so gracefully. It was amazing. So there's not been a single Java project where there hasn't been something like a util package or a commons package. I'm still a big fan of that because, first of all, nobody is responsible for that. And second of all, everything ends up in that package. It doesn't look like I want to take commons. Goodbye. So this is something that we probably can't do in microservices. We shouldn't have done it back in the Java EE days either, but it was just convenient, right? So we finally get something like componentization, encapsulation right. And we are forced to think about separation of concerns a lot more than we did. Because instead of having everything in a single deployment unit, everything might be potentially distributed. So we really need to think about who's doing what. Loose coupling, a no-brainer. We've tried that. Like my favorite still is web service calls. It kind of worked, but hasn't been a good thing. And there's also been a couple of new architectural approaches. I don't think they are actually that new, like the hexagonal architecture, but they haven't been on the radar of the classical architects for a while. And I think we can assume that I'm still talking about the enterprise guys. Software design patterns. You had a great talk before this one about domain-driven design, I think. Was it that one? Or test-driven? It's not the same, I know. Domain-driven design is something that I think has been underrated so far and underused, especially in the classical enterprise projects. It still is the most valuable tool that you can have at hand if you're really looking at building microservice-based systems. Bounded context as the corners and boundaries for microservices. A couple of other things. Would a microservice-based system work with classical JDBC architectures as data stores? Opinions? Ideas? Maybe? Anybody? Nobody? Why not? Sure, why not? It would even work with .NET persistence, however that looks like. We actually don't care. The funny part is it's not optimal. There are a couple of things that you need to keep in mind. So microservices aren't monolithic applications. They don't get called once and wait for all the information to come back to the user's browser, for example. They actually have kind of a more granular usage pattern. So they get potentially called a lot more often than a bigger service, how we're actually designed them out of SOA times. And underneath is everything that has to do with data. There's no serious enterprise application without a reasonable database. So what's the biggest drawback of databases? You can actually optimize them for either reads or writes. You can't have both. So no ARMs, no cookies. What's actually the thing that our DBAs did in the past? They did their best to do something that is exactly in the middle. kind of fulfill the read requirements and kind of fulfill the write requirements. There are actually other approaches to that. Why not have two separate models and optimize for the exact use case that we want to have? And this is something that CQRS actually allows you as a design pattern. There are a couple of frameworks out there, and I'm again shooting against the Java world because those probably are concepts that we all have heard about. The bigger accounts that are looking for modernizing their applications and their legacy today, they haven't heard about that vocabulary at all. And they're just slowly finding out that there are different ways to architect applications. And this is the most interesting part. So we actually have to educate them about that and make them aware that you can have both. That you can have a use case that is write optimized and a use case that's read optimized. Perfect, great. Another thing that has been talked about a lot in distributed application development is eventual consistency. This is something that mostly the read optimized side in CQRS systems kind of is suffering from, but the whole system might actually be designed to handle that. And instead of preventing failure, which has been like my biggest design paradigm over the last couple of years, those microservice-based systems are actually embracing failure. They are expecting failure to happen everywhere and any time. And they know how to handle it and make it work still, at least to the best possible amount. And those thought models are something that you definitely need to keep in mind if you want to switch some monolithic application over. Burning all that down to one sentence, and I'm actually not even sure if, I think it's a quote from a Red Hat guy. I think it's a former coworker of mine. He said, we need to stop building systems just for efficiency and robustness, which is something that we did. We need to start building systems that are flexible and extremely resilient. And this is exactly where microservices come in and help you with achieving exactly those goals, right? The slides will be available afterwards anyway, so. You've seen that, right? What's it? The 4 big tenets, right? Reactive Manifesto. Yeah, that looks all familiar, and it actually is familiar. And that's the most interesting part to me, that the world is turning slowly but consistently into a direction that we all know probably since a while, but nobody else out there thought about when they designed the term microservices. And do you know where that initially came from, like the term? Who made that popular? Company names are okay. I think it was Netflix, right? So that's where we all kind of were hooked up with everything that had to do with microservices and REST-based approaches. And that's funny. And also Amazon did that years before that, just internally, and they never really talked about microservices. I think that's all driven by the conference circus, maybe. So we're all looking for the next big hype. Gartner today released something about the next big thing, serverless architectures. So microservices are, as of today, officially old and outdated already. So I need to start talking about serverless architectures. But yeah, it all burns down pretty much to the same principles that we've been working along, and that's reassuring and really helpful at that end. So whatever you know and whatever you learned at Scala Days about Scala, Akka, Play, those are actually pretty great fits for microservice-based architectures already. So we're done here, or we can go, right? That's it. Microservices are exactly that stack, and we're all going to do that. If you throw somebody in there who's actually starting with that world, with the reactive world, 1, 2, 3, 4, 5, a reasonable amount of people. What have you been doing before? Like, what's been your main language? Java? How does the stack feel? Just honest feedback. How easy is it to get from Java to Scala and Play and Akka? Don't think so much.
an executing model. Scala basically gives some rules for implementation.
But it's a different world, right? So instead of using Maven, we're using SBT. It's a different world, after all. And what I experienced talking to the Java developers out there and trying to make them excited for everything around microservice, resilient microservices, actually, they said it's a pretty steep learning curve. I had to spend a lot of cycles to actually get started with all of that. And where's my Maven? And yeah, I get that. I get that. I mean, if you've been doing Maven for, what, 5-10 years, you probably don't want to see anything else. And you still would have to build a lot of infrastructures for microservices yourself. Service registry. How do you do that? I mean, you can map actors to services and can have kind of a thought model around that. But still, it's not a complete thing out of the box. And actually, those technologies have never been built for microservice architectures. They've been built for resilient architectures, and that's what they can do best. And this is exactly, we're getting there finally, where Lagom comes in, and I acknowledge that not even pink, it's like whatever on blue doesn't really work well here. So that should be the Lagom logo. Sorry for that. So what does Lagom change in the whole game? Lagom isn't a complete framework. I'd like to call it an optimized layer on top of Akka and Play. So instead of having to mingle around with the individual technologies, you can just use Lagom and have a very, very complete developer experience without having to build all those individual technologies into something new. And it also takes care for the service definition itself. We have a service API. You don't need anything to bundle your individual builds together because Lagom has a very opinionated framework to make that happen for you. And most importantly, you have something that takes you all the way from the individual developer machine to the distributed system in production on various nodes wherever they are. And this is exactly what Lagom was built to. Inside Lagom are exactly the technologies you would have expected. SBT as a build tool, as it is a lot more than a build tool. It is like a development environment. And it will help you a lot to be productive. Hot reloading issues, gone. Starting individual services like Java jar in terminals, gone. SBT and the Lagom development environment allows you to fire up a complete microservices system, including a local database, including all the necessary services that are included in your system, and it fires up everything with a single command. Persistence backend in this case is Cassandra, and for the local development and service discovery, it highly relies on Google Juice in that case. Somebody heard that before, maybe. Highly opinionated, what does that mean, actually? It means we don't let you do everything with Lagom, first of all. If you are using Lagom, you definitely decide to implement microservice-based architectures. And we have various APIs ready for you to use that help you implement the principles and design patterns without too much thinking about it. That's first of all a service API, where you can actually implement a service interface. So for everybody out of the Java EE, like it's kind of a servlet based, a standardized API that you can just use. And I think I've not seen that before anywhere. So Lagom has a service API. And we have a persistence API that is actually capable of delivering CQRS features. So you can directly implement that. You don't have to think about how. Lagom guides you with a very strict API. We talked about the development environment, and the production setting environment is also included. Every hook that you could need, every service interface to put your individual services into production is also part of Lagom. The service API basically takes care for everything that has to do with communication between services. You don't have to think about how calls are constructed. You don't have to think about how services communicate with each other. You basically just implement your bounded context definitions, and you can use them, the services with various endpoint technologies, and can also use them from service to service calls, so intra-service calls. All on a single API, without having to learn Akka that much, without having to learn Play that much. So it's all nicely encapsulated with a very fluent API in that case. The persistence API, I think my biggest advantage here is that it totally turns everything I knew about JDBC and JPA upside down, because it fully relies on CQRS. So instead of persisting complete objects, we're storing the deltas in terms of messages. So event sourcing is the big thing behind that. We're basically replaying the state of individual entities through capturing the individual change events that happen. And that has a lot of advantages. So if you want to construct a read side for your persistent entities, you can basically choose at any given point in time what part of the entity you really need. So you can have a read side that only grabs like the first 3 attributes of your entity and expose that as a table view. You can also expose the complete captured events and the complete attributes of your entities. You can still use something like CRUD and JDBC access, even in Lagom services. Just don't use the persistence API in that case. And that's exactly why it's highly opinionated. So you don't have a big choice if you want to go that way. This looks like Spring Boot. It's not. It's actually SBT firing up your local development environment. And it's actually just one command. I've been using Activator here. It doesn't matter. You can just simply use SBT. And the command to fire up your service system is run all. That's pretty much it. You get your service locator, which is used internally to look up the services. And you have your gateway running, which dispatches requests from client to the individual endpoints. The next steps for Lagom are pretty easy. So we're that close, maybe even closer to a 1.0. At the very moment, it's still a technical preview. We are looking at a Scala API. I apologize for everything being Java right now, but this is exactly what you get when you start to try out Lagom today. It's Java-based API first. You will find the deeper you dig into Lagom that the service coupling at the very moment is comparably tight, and it's actually binary. And we want to break that up, so there will be a Swagger integration to really separate the services from each other. And because everybody has been screaming for Maven support, especially those legacy Java developers, and maybe even myself, we will get a reasonable Maven support. The idea behind that is that you can actually integrate existing Java-based libraries or modules or features into your newly built microservice-based system without problem. There will be more support for CQRS and various DBs. At the moment, it's still Cassandra and nothing else. And I think the other part is the operational side is based on Conductor at the very moment, which is something that not all of us totally support. There is a community project who is writing an integration for Kubernetes. There are a couple of initiatives around having Lagom based on DCOS, like Mesosphere Data Center Operating System. So there's a lot of stuff coming up. If you feel there's something missing after you looked at Lagom and start to play around, just let me know. Send me an email. And I'd be totally happy to get that feedback in and talk to the team about it.
What is Swagger?
Sorry?
Swagger?
Swagger is actually an REST API description. And dynamic REST API description. So that's kind of, what is it legal to compare that with with the DSLs, the web service DSLs, maybe. We'll see. Okay, you find Lagom on GitHub because the good news is it's open source. So just give it a try, play around with it. We have a great mailing list where all of our engineers are reading and, most importantly, answering. You find Lagom on Twitter, and I have to admit that's mostly me. But again, I like it. And we also have a chat room, which is pretty cool. The idea behind Lagom is pretty simple. It's exactly that book. Jonas wrote it, and it contains the architectural principles behind reactive microservice-based systems. It's totally free to download. Just give me your name and your email address, register on the site linked here, and you can download all kinds of copies, PDF, ebook, formats, various ones. It gives you a very, very solid overview and is probably the best read for architects in general. You've seen that one in your attendee bags. If you don't want to take it with you, just download. Again, the same procedure. It's free. You can share it with your peers and just give it a try to get your first hands on Lagom. And this is actually where you can access it. So this is the GitHub project URL. I really have a very nice project site about Lagom up. There are a couple of introductory, like 3-minute videos that you could watch about all aspects around Lagom. And the documentation is pretty awesome. No, it's not. It's documentation. Seriously, wake up. No documentation is perfect. But it's a very solid start, and it's one of the best ones I've seen in a while. And again, if you have any ideas about how to improve the whole thing, just let us know. There are a couple of ways to get in contact with us. Thank you for your time. Safe trip home.